All right, hey guys, you've got your quiz coming up. It's Monday, so I thought I would go through this quiz review sheet with you guys. I did a lot of this in class, but again, it would be nice to hear it a second time. It would be nice to maybe work these problems again. Um, so here goes. Starting at the top, there's a blank here. It says for any right triangle, blank, where A, B, and C are legs and C is the hypotenuse. So here what they're going for is the Pythagorean Theorem. We're not hopping into trigonometry yet. There's no sine, cosine, tangent. First thing we're doing is just the Pythagorean Theorem, which says a squared plus b squared equals c squared. And again, the most important thing to remember is c has got to be the hypotenuse. And to remember that a and b are the legs. And A and B don't really care which leg is which, but C has to be the hypotenuse, okay? So jumping in, if you're going to solve for x here, you'd start by writing the formula. And then I think what I like to do is find that hypotenuse and get that plugged in for C right away. That's going to be our x. Then the A's and the B's, they don't really matter as much. It's the 9 and the 17. When I say they don't matter, I mean you could put 9 and then 17 or 17 and then 9 and it wouldn't matter. So I'm going to go 9 squared. Then I'm going to go 7 squared. And to calculate this stuff, I think all of us know by now, but 9 squared just means 9 times 9. If you didn't know that, I lost something. Oh, no, there it is. All right, I have a little calculator. So this calculator is kind of like the ones in class we were using that were not that great. Would certainly be better if you had the graphing calculator. But even a calculator like this, if you want to do 9 squared, you literally just type 9 times 9 equals. And you'll get your 81. Okay, it's just as good. There's a squared button on here. You could hit 9. And then this button here is for squaring. You'd hit that. And you get your 81 a little faster. But either way, we can do that math. Let me move this thing. We also need 17 squared. So to do 17 squared, I can't see the mouse. All right, you'll just do 17 times 17. It's probably the easiest way. That's 289. So turning that thing back off. Just fill those numbers in. We just said 9 squared gives 81. The 17 squared gives 329. Now I feel like I want to double check that. 289. Yeah, okay. Okay, this is 289. And that's x squared. So here, since these numbers are both on the same side, you just go ahead and add them like normal. So adding these up, you'll get, what? 370? But 370 is x squared. So of course from here, you got to take the square root. And then you got a choice. You can give me the answer as x equals the square root of 370. Or you can do it in your calculator and get a decimal that you round off. So bring in that calculator back one more time. If you had a number like 370, you can type in 370 and then hit the square root button. Poof. And you get 19.24 because we're rounding to 2 decimal places. So it's 19.24. And then that's it. You could give either of those answers and it would be fine. And also I know it says 10th up here, but I don't ever want you to round to the nearest 10th. I always want you to give me 2 decimal places. That means the 100th place. Okay, and you can't see that. There you go. It says 10th right up there. Alright, it's getting late here, and I'm getting tired, but I'll keep going. Number 2, I would write out the theorem again. Just really keep writing it until you've got it in your brain. So now, again, I like to take the hypotenuse and plug it in. So you'll notice that number 2 is different because this time our variable is going to be one of the legs. We're going to have 11 squared plus x squared. But in the first problem we did, x was c, so x was all alone on one side. But here, x is kind of in the middle, it's over here on the left, it's got something else. So the math's a little different this time through. But you'll take 11 and square it, you get 121. You keep x squared. You take the 14, square it, you get 196. But now, our goal is to get x alone. So subtract 121 from both sides. On the left, it cancels, and you just keep the x squared. On the right, you're left with 75. So again, that means you could take the square root of both sides, and you could just give me x equals 75, or if you really want to, and we'll go to the other calculator this time. Depending on which one you have, you got to know what to do. But if you had this TI calculator, the graphing calculator, then to do a square root on it, you actually type the square root button first. So you hit second, square root, and then you type in the 75. And then when it's all there, you hit enter. And there's your decimal, 8.66. So we need a radical on this. Can't just be 75. It's got to be root 75. But that's the first two. And then there's two more. For number 3, I guess let's keep the calculator up. Probably going to need it. Let's just move it out of the way. All right, so for number 3, again, it's Pythagorean Theorem. So just write out the formula. And then plug into it. Again, making sure the hypotenuse, the 8.1, that's got to go where c goes. Then the other two legs are 6.8 and x. And that's it. We're going to solve by, squaring these numbers and subtracting. So where am I? Where's my calculator? Here it is. I got to know what 6.8 squared is. So you can see we're getting 46.24. I got to know what 8.1 squared is. And it's 65.61. So if we keep on going, 46.24 equals, can't read that, 65.61. And notice I'm not rounding these numbers off. That is exactly how we got them in the calculator. Normally, if you're taking numbers from the calculator and you're not done yet, you should take probably at least 4 decimal places. Because if you round everything off to 2 decimal places, then your final answer won't be accurate anymore because you're losing more and more precision. But these numbers don't have that problem. These really just are the number squared. It's not something we're rounding off. So the next step is subtract 46.24 from both sides. You get those to cancel. You get an x squared that equals, and I'm not going to do that math in my head. It looks like we want to do the 65.61 minus, and you can go get the old answer. If you use the arrow keys on these fancier calculators, you can get that old answer by just pressing enter rather than having to retype it all in. So that's kind of a time saver. But I'm getting 19.37. And then of course that's not the final answer because we have to take the square root. So the answer is the square root of 19.37, and I would do that out if I were you. Just get your calculator, put your radical in, 19.37, Press enter. And I'm getting 4.40. So that's probably the best answer for that one. And what I mean by that is we could sort of leave our answer as the square root of 19.37, but I wouldn't. Having the square root of a decimal looks weird. You may as well just take the square root and get a smaller decimal. All right, but let's do 4. So there's 4. It's over there. And it probably wants to be bigger. So let's just do this. Okay, that's plenty big. So I know that some people had confusion here, but if these markings are here, those markings are meant to say that these two sides are the same. So this one being 18 means this one's 18. And at that point we realize that the 13 does not go for that side. 13 is the altitude, or the height, that drops straight down right here. And that gives us a right angle. And that means this triangle that we had can be divided into 2 right triangles. And then if you're trying to solve for x, what you want to do really is solve for y first, where y is this horizontal leg of this orange triangle. And we can solve for y pretty easily because, well, it's just Pythagorean theorem like before. So the Pythagorean theorem says that the leg plus the leg equals the hypotenuse. So leg squared at least, y squared equals 18 squared. So it's kind of the exact same kind of problem. The 13 squared gives you 169. The y squared is going to stay y squared for the moment. 18 squared was, what? 324, right? 324. All right. So again, to solve, we got to get y alone. To get y alone, you'll subtract 169 from both sides. Then you're just subtracting those numbers. So 324 minus 169 leaves 155. Now you can take the square root of both sides. And you can, again, you can give your answer as root 155 if you want to. Or you can actually just do that square root out and see what you get. So I'm going to do that, I guess. So second square root of 155, sure, is giving me 12.45. And that's it for that. And that's it. Oh no, that's not it. Sorry. What we just found, of course, was only y. And we're trying to find x. But I think it's pretty clear that if the blue chunk is y, the yellow, the green, sorry, I'm getting very tired, I think. But if that's y, then this must also be y. And then we can see that x is just y times 2. And we can just double this in our heads probably. 12 doubled makes 24. 0.45 doubled makes 0.9. So that number there must be x. Okay, moving on. So for 5, we talked about the Olympic-sized swimming pool. But an Olympic pool is in the shape of a rectangle. It's not like a circle or an oval like some other swimming pools you might have seen. But we know that one side should be 25 and one side should be 50. And then we know that they want us to find the length from corner to corner. And that's no big whoop because we can put a right angle here because this is a rectangle. And then we're solving for this distance here, and that distance is the hypotenuse. So the Pythagorean theorem is going to say that the 25 squared plus the 50 squared is equal to d squared. And all these numbers are pretty big. 25 squared is 625, and 50 squared is 2500, and that equals d squared. Adding these numbers together would give you 31.25. Oops, I don't know why I said point. 3,125 is what I meant to say. And that equals d squared. So to get your final answer, you have to take the square root. And if I take the square root of this number, it's going to be whatever. So 3125. Okay, 55.90. And don't forget to include your units. So for this problem, it's meters. It says right here, meters. It says right here, meters. So you got to read the problem closely and make sure you understand it, and also make sure you know what the units should be. All right, 6. Did I mess up on 5? Kinda. I see that I left the calculator in the way of the illustration. Hopefully that wasn't too bad for anybody. I'm going to move it just real fast. This was the drawing I did for the Olympic size problem. You draw the pool, you draw the 25, you draw the 50, you draw the diagonal. That's it. It's just a right triangle. So let's do 6. 6 says a 20-foot ramp is being used at a loading dock for a factory. So I'm going to draw green grass as the ground. Then in concrete gray, there's a loading dock up here. I don't know where it goes, but I know that it's up off the ground. And that means that any truck that tried to unload its stuff would have to park here, as close to this thing as possible. And then you could make a ramp coming down. And that's what it says here. We've got a 20-foot ramp. So this hypotenuse that I just drew, that's the 20 feet. And then if you keep reading, it says if the base of the ramp is 19 feet from the base of the dock, well, here's the base of the dock, and here's the base of the ramp. So they're trying to tell you this distance. And they're saying 19 feet? Yeah, so we throw 19 feet in there. Okay, and then what we're trying to solve for is this height right here. So if you can read everything and understand it well enough to get this drawing, then from this drawing it's pretty obvious. We've got two sides. So this is just going to be another Pythagorean Theorem problem. And 20 is my hypotenuse, so that goes in for C. And 19 and h are the legs. So 19 squared, h squared. So how much of this can we do? 20 squared will be 4. We're squaring, so just 2 zeros, 400. 19 squared, I don't know what that is, so just bring our calculator back. Okay, 19 squared is 361. Okay, so now to get x alone, you have to subtract 361 from both sides. And you get x squared equals 39. Or x equals the square root of 39. Or x is approximately whatever the square root of 39 is. So 6.24. Yeah, so that's it for that. And I think that brings us to the next kind of problem, these trigonometry ones. So I'm just going to stop here and I'll kind of break this video up into parts. But yeah, that's part 1. I'll talk to you more later. Bye.